Ciao Alessia, come stai?
Bene. Mi sono data...
Ciao.
Però penso che ci sono le registrazioni.
Sì, sì.
Ok.
Okay, shall we continue? Do we have a person, the lady was working on the simulink? No? I guess not yet. Hello, hello? Are we ready to continue?
Yes, Professor, but I tried to complete it, but it's not working.
Yeah, of course. That's why we should continue. Let's take a look.
Okay. So,
it's impossible
okay.
that something this complex works the first time around.
So before I introduce,
Sorry, Professor, I can hear you very well. Maybe
Cannot?
maybe there is a sort of echo. I don't know.
Yeah.
Wait a second. I put the.
Better? Oh.
What about now?
I think it's better now, yes?
Okay.
Yes.
Okay,
Thank
sorry. Okay, so it was working if I used as gamma dot and omega dot the constant as I had it before,
yeah.
and it's not working now.
Okay.
So I was trying to understand what happened when I defined this.
Seems like the dimensions of what's coming out do not match. So it understands that your initial conditions for the numerical integrators are dimension 3, but what it's coming out of the block says
yeah.
it's 1. Can we go in for 1 second and see what's going on? So omega dot is 3, gamma dot it's 3. Okay. Let me see 1 second. Can you go to edit data? This is a brute force approach on top. You know, all those options you have in the.
Sorry, where is it?
The right. Go right. Yeah, there. Almost edit data. To the left.
Yeah.
That
one. Okay.
So let's see. Yeah, see the outputs, omega dot, gamma dot. Let's see what it's doing with them. Okay. -1, so it should be. I mean, you can try to manually force it to be 3, because it's inheriting whatever was there before. So for some reason, I think it memorized that it's
like this.
Yeah, and then the same for gamma dot. I mean, this is not something that we should be doing, but I've seen it being a problem before. Yeah, apply, and same here. It really shouldn't be the way to solve it, but let's try if that's
okay. So
run.
I don't have the right time for the stop time because otherwise it takes too long.
Okay, so then there is an algebraic loop, derivative 1. Let's see what's happening to derivative 1. Let's go there. Oh, yeah. You may need. See how I've done that. So you have gamma dot, and then you have gamma double dot. Well, hold on. Do you need gamma double dot? Oh, wow.
Yes, for
If you want to include it, which you can also not do. And in fact, I don't think, no, I do have it, actually. Where do I get that from? I'm just using my model as a reference, I'm sorry. So it's coming from this thing. Okay. Yeah, I have a derivative there. Yeah, okay. Interesting. Why is it not liking that? Let's see. So I do more or less the same you do. I take the gamma dot signal and it just goes
here.
into the equations of motion pretty much.
So
But,
essentially, this goes here.
right. It doesn't like that. Huh.
Maybe I can try to comment this term here and see if it runs, and then to see
No,
if this is the only problem.
Yeah, an algebraic loop is basically telling you that I think what it's telling you, the first time step it tries to run this thing, it doesn't have the initial value. You need something to be able to compute the derivative, and it cannot. Because you need two.
Yes, because when we perform the integral, we set some initial condition, while here it still doesn't.
Yeah,
it still doesn't have an initial condition.
But I think I have something done the same way. I have two derivatives without doing anything that looks different from what you do. And actually, it's not complaining about the omega dots, though, right? It's not doing that. So the omega
No, because
omega double dot, I mean, because you do need that. Or I'm sorry, omega desired dot. Maybe you're not doing it yet.
no, omega desired dot. Yes, I compute extent. Yes, I do compute the derivative. It
And it's
comes.
not complaining.
No.
Can I see where you do that?
Here.
Yeah, see, it's, what is it? Yeah,
It's
and I
here.
do it the same way, and that's fine, and it's not complaining. But then this gamma double dot, for me, is just coming from eta, and I pull the signal, and I just do its derivative. That's weird. 6. Yeah, that's really weird. Anyone online is free to comment if they have any ideas. I'm trying to find why it's complaining. Can we look at the other errors too?
Yes.
Okay. Function A, algebraic loop error. So it's not just there. Function 8, function 4. Yeah, well, that's the one that receives the gamma double dot, right?
This is the one. Let me see. No, this one is the one as an that has as an input gamma double dot.
There's an error for that one as well. Yeah, there is an error for that one as well.
Then also this one here. Okay. And this one.
Okay.
Yeah, basically all of them.
Model properties. Now, I wonder if there is some setting in general in simulink that. By the way, what numerical integrator do you have?
The one that we set together. Let me check, but
Shouldn't matter, but you never know. Solver.
here.
Okay. So for this particular one in my model, I even relaxed things. I think I have 0.1 max time step and 10 to the minus 6, but yeah, it doesn't matter.
So I don't change them.
I mean, it's up to you. But it's gonna run super slow, so maybe you want to do 0.1 and the other one 10 to the minus 6. In my case, it's working. Okay. Algebra loop or no? No, before you close. Oh, you closed it. Can you open again?
Sorry. Yes.
That's fine.
Sorry.
In the diagnostics. Now you are the same. Okay. Let's look at the error message again. Non-double? Such as blocks with discrete valued outputs. Yeah, one typical way is to put a memory block in front of the thing and it will solve it, but it's not really, I don't think we should do that. Okay.
You mean?
Yeah, before you go into the time derivative. But again, you shouldn't. Can I just play with your model real quick?
Yes.
So, okay, this is what is happening, right?
Yes.
And then it goes in here. What else?
Basically everywhere. Here and here.
So this block is doing what? This block is doing the matrices, right? Actually, it doesn't go here.
Yes, because again there is a problem with omega.
No,
Omega
but,
double dot only goes in this one.
No, the gamma double dot. Yeah, it doesn't go. In
Sorry, gamma double dot. No, gamma double dot only in this one. I
okay,
think.
so it goes in this one, and that's fine. I'm gonna. Okay, just because I don't see it that way. The gamma double dot. Okay. And he's not liking that. And then, oh, okay. So, okay. So what basically it's telling you is that you compute the gamma double dot and it's like you're feeding it back in here. And it doesn't know what to do with that at the initial time step, I think, because in order to feed this block that will allow you to take the time derivative, you need information from this one. You know what it means? It's just that's what the algebraic loop is. And same here. I believe that this is outputting stuff that you need for this one, right? Yeah.
Yes.
So how do we do this? I do have, okay. So I do have a memory block for eta. So where is eta comes out of this block, right?
Yes. No, the other one. This one, the last one. So I never have eta, I just have omega dot and gamma dot. But it's in here that I defined.
So I had the same issue, and then I integrate them separately, but you can do it for each of those signals. I do have a memory block. because it needs something to initialize the eta variable.
Right. So.
And I simply have a memory block. In my case, I output just the eta and then I use it somewhere else. But I do have a simple memory block in front of eta before it's used somewhere else, and that's solves the problem. It breaks the algebraic loop. It gives it a 0, and you can choose because that's your controller, right? So eta is your control variable. It's the gamma dots and the omega dots. You can choose that they start all at 0 or something else. It's up to you. It's the initial condition for the control variables, the gimbal rates and the acceleration of the wheels. And I would say we can start at 0. It's a reasonable assumption. And so if you broke it in 2 pieces before you can put 2 memory blocks, one in front of the omega dot coming out and one in front right after the gamma dot coming out.
Okay, so
it is one way to avoid the algebraic loops, because it just means that it doesn't know what to do at the first time step.
but you mean any time that I have coming in, for example, an omega double dot here, I should put a memory block?
No. Here. So right after you generate the omega dot, put a memory here and put another memory.
Okay.
Because if you think about it again, they are your control variables, and it's since we choose them, because we choose them with that formula that you've implemented. But at the first time, what do?
Yes,
that formula requires an initial value, really. What is it again? The formula. Yeah.
And also here.
Well.
No.
The way I have it is actually before everything, right before even the numerical integrator.
Okay, right. Yes, that was stupid.
No. It's actually, if you think about it, it's not necessary because the yeah, no, I will put it in front of everything else. That's easier.
Okay, and so here also.
Everybody else online, are you working in parallel on this?
Yes.
Yes.
I'm sure there will be another error coming out now, but maybe that one is gone.
Oh, sorry, forgot to put the right initial conditions.
I think in my case, I just have a 0 there. You know, he understands that everything else is starting at 0, even if you don't put a bracket.
Okay. Anyway, okay, so let me close this, and try to run it.
Okay, something else. Ooh, I give you the wrong suggestion. Derivative. Wow. Well, I think the solver is fine as it is. It's just that something is happening, and it's.
Maybe it's because I use violating the step size of.
So you have variable step OD45, max step is 0.1, relative tolerance is 10 to the minus 6?
No. Okay, sorry. I thought it was open.
Yeah, but I don't think this is gonna make it better. Maybe. I'll be this thing.
Okay, shall I try?
Oh, well, yeah. Yeah. Okay. Matrix is singular. So there's a matrix that is actually singular.
Ah,
Mm-hmm.
okay. But it doesn't tell us which matrix, right?
Well, first thing that comes to mind is whenever you invert something, that's probably the problem, right?
Right, so
Not one spot where you do an oh well, no, there's more than one actually. Even the eta has inverse functions. Let's look at the eta expression first.
so I have an inverse here. Q star W and Q transpose. Maybe
Yes.
I wrote W the wrong way. It could be
Oh,
that
yeah,
if I put
yeah,
something
actually.
off diagonal, it could be singular.
Yeah, maybe.
Okay, so the first three are on the um looks
Okay, right?
sorry?
It seems okay. And the initialize is the same. I assume that you have
Yes, I used these conditions.
minus mu delta. How do you compute delta again?
Okay, let me see. I have it here. It's the determinant of C times C transposed.
So we may have some issues with the matrices. Remember that you wrote them in a compact form, and maybe there's some error there. So
The
yeah.
fact that is that it was running before I then closed the loop. So
Well, but you were not inverting. We were not doing this, right?
no, I was doing everything, simply just giving zero initial conditions for sorry, zero for omega dot and gamma dot.
I see. Right. So was this block also running?
Yes, all the blocks were running.
Grazia, but
Sì.
if you change capital Y 1 in capital Y 1, comma 1 in the C equal to right.
Yes, because we realized that I was making a mistake. Instead of writing every time Y capital Y 1 1, I was writing 1 2 and 3, assuming that it would give the diagonal elements, and it was not. But 1 should be still the first element. So
Yes, better.
I mean, the problem was with these two.
So I'm thinking if you, so you're saying that when you close the loop, things stop working,
Yes.
and the algebraic loop is gone. So this is one place where you invert a matrix, and the other one is in the actual equations.
Yes, when I invert J total here.
you see. It's J plus C1Y, C1 prime, C2, Y2. Okay. Why is it singular? Where is it singular? The error doesn't say. Does it say in which function it is?
No. I don't have it anymore. I don't know why.
No.
Let me run it again. Okay, so it's in this block here,
Maybe.
apparently. So at least it's this numerical integrator that is not working. And this is the block that is integrating the motion, so where I invert J total.
Are you sure that's the block? Because I think it's more than just that one.
Derivative of state 1 in block is not finite.
Okay.
Oh, so the derivative is not finite.
Well,
so
and then as a consequence, you cannot.
So maybe it should be J total to be singular, because the derivative is singular, but everything is finite. So it's this one to be the problem.
So J is the J that we gave. Can you check the initialize just in case? Yeah, that's the one.
Where do I have it? I called it J1. Here it is.
Oh, it's very different, yeah. So the one that I'm using for the this homework, and I think this the initialize I gave you as that line commented out, and it actually has. Oh, I still have control. This one. Can I? Of course, I cannot copy paste from my computer to yours. So, did you change this file? I think you did. No?
Yes, I
So
changed
anyways,
it.
it's the one with 87, 85 points, so it's a different. Let me put it in the chat.
Yes, thank you.
Chat here. So, yeah,
Okay.
I don't know why I should make it singular, but I'm wondering if you have an inertia matrix of the main spacecraft that it's comparable to that of the variable speed control moment gyros.
Is it?
Should not go singular.
So it should be this one, right?
Yeah.
Let's try.
Yeah.
No, it's always the same.
Yeah, I mean, it shouldn't ever become singular, even if the values are big or small. It shouldn't. I mean, if it's a matrix of inertia, it shouldn't. So something is obviously, I think, there must be something going on with either the C matrices really that make that become not invertible, while it should be, because it's the addition of inertia matrices, and it may be that the C's are wrong. That's the first thing I can think of, assuming that we have the same Y matrix and the same J matrix now. So let me see.
Because Y is just the diagonal, this diagonal matrix.
Yeah, they should be the same now. So let's look at the C matrices again.
The C matrices.
1, 2, and 3. Okay, let me
Here
see.
they are.
Okay. The initial conditions, are they in this block or you just use them from outside? Okay. G 0. Huh. So G0 is coming from outside and it's what? It's the three of them together? G1,
Yes.
3?
Yes. It's
G1,
G1 0, G2 0, G3 0.
Okay. And then S0 is S1, 0. Hold on. S2, 0, S2, 0, T1, 0, T2, 0, T3, 0. So we go into this one? No, this one. Okay, so you're saying that AG1 is column 1, column 2, column 3. Seems like you're doing the same thing twice, right? AG and G0 are the same thing.
Yes.
Okay.
Yes, because AG is constant.
Okay. AS. One sec. So, cosine is first one, sine. Oh, there's a minus miss. No. I'm sorry. No. Doing all the S's together. Oh, okay. Yes. Cosine 2 was 2, T2. Okay. Then the T is cosine minus sine. Okay. So, this is where we do things just differently. I have just GS and T.
Yeah, in fact, it could be also directly, yes, G1, S1, and T1.
I mean, it should.
But it should be the same. Again, we discussed this because those are all given in this coordinate system, so it should be exactly the same.
So an attempt to see if this is the problem without going too much into the details is commenting out these lines and assigning C1, 2, and 3 just directly as GST.
Yes.
If that solves the problem, then if you want to comment everything out, you can select everything and then control, what is it, control R, I think comments everything. Yeah.
Okay. So let
That way
me.
you don't have to change the way it looks like. You just comment everything out. And then control T will uncomment.
Control?
R, as in Riccardo. Yeah.
Nice.
And then, so yeah, C1 would be G1, comma, I think that's how you call them. I don't know how you call them. AG1 probably.
G1, right? I don't remember.
Yeah, I think
yes. Yes. AG1.
AS1 and AG1.
S1. AG.
Actually, the way, so I don't know, are AG1, AS1 and AT1 column vectors?
I think they are because.
So no semicolon, it just needs a comma or nothing between them.
Oh, right. Sorry.
Yeah. So the same for the other two matrices. Let's see.
Yes.
till unless there's a typo in the previous matrices, it should be the same. Okay. In fact, that's not the problem. Can we ask MATLAB to show C1? Yeah, you can. Just remove the semicolon at the end.
Sorry, what should I do?
If you want to print them in the workspace, you can. Oh, it's not the right one. Here. If you remove these, you will print them out. Also, you can stop. You know, you can run things, and hopefully it will stop there and show me. Okay, and then I do step, and this is C1. And that makes sense, right?
Yes, I think.
First time
yes,
step.
because.
Second time step. Okay. I think I don't remember how I oriented those things, but seems like okay. And then let's see. I want to go here, right? And see what this is. Oh man, what have I done? Let me start over again. Does this one clear everything every time? Does it clear the variables and everything when I run?
I think so.
It doesn't even get there. It doesn't even get there. What was the other inverse again? Was in the, not here, right? Maybe? No. This one.
Yeah, in this one. Yes, in this one.
Okay, it's here then. Must be. Okay. Three-dimensional torque. Q is this thing. Q is a symmetric positive. No, Q is just assembling those two, right? C and D. Okay. All right. Is it gonna like this? It did. I don't see a problem. Step. That's what it is. Okay, let's see if it does another step. It does. Keeps going. We don't know how many steps it's gonna take before it crashes, and I don't think this is a good way to do it. Interesting. Well, just for fun, let me go back to what you had. This is not going to solve anything, but oh, I need to remove the breakpoint. Where are the functions? Go away. Okay. wonder how long it's going to take before it crashes. Wow, right away. So there's definitely a problem. Okay, well, we think the C matrices are okay. Then the next step is 1, 2, 3, 1, 2, 3, 1, 2, 3 is the where we put together this. Yeah, this is the function where I wasn't. You've done it in a different way, and I'm afraid there may be some issues here. So let's see. All right. So M, what is M? Omega 1, omega 2, omega 3. Then you have omega x. I need to write these things down. M is omega of the gimbal. What is OMG?
No, it's capital omega. It's the spin rate.
So yeah, the reaction rate.
Yes.
So that's a matrix that has omega 1, omega 2, and omega 3 in diagonal.
Yes.
Okay. And then you have omega x, the skew symmetric matrix. Can you check that that's correct? That could be something else. Then, okay, B. We're going to jump to B. B is, in theory, it would be G1, G2, G3 that multiplies the Y value 1, 1 times the identity matrix, right?
Yes.
And you're simplifying this, saying that it is that AG. So AG is
It's the one with the G's as columns. So it's exactly the one we need in B.
I think that the error must be there in one of these expressions, right? So, okay. It is a 3 by 3 matrix that multiplies another 3 by 3 matrix. So yeah, that's fine. Do my own calculations here. One second. Yeah, okay. Then D is the other one that should be relatively simple to put together. What is D?
Here.
And then C. C is really the monster here. So what you've done is E1 is AS transpose plus AT transpose times omega plus omega desired. Same. Okay. So you're saying that C is the first term is the diagonal matrix I'm just wondering if in these simplifications we're missing some transpose, you know?
You mean when I take the values out of the identity matrix?
Well, the identity matrix transpose is what it's the same, but and you have this skew-symmetric matrix that that multiplies gimbal angle diagonal omega 1. Yeah, I'm sorry, I11 plus 1 over 2 you have this diagonal of 2 y2 minus y3. Yes. I mean, by just looking at them, I don't see the error.
Sorry?
By looking at them, I do not see necessarily the error. But
Okay.
I can definitely, since in theory we have the same exact initial conditions, right? So I'm going to put a breakpoint in mine and run it. I'm going to do the same. Get to compute Q, basically. Run that. Let's see what my B looks like and what your B looks like. So if you go with your mouse over B, what is it looking like? Not showing?
No.
Why not? It shows, maybe I should stop controlling. Try now.
Okay.
Okay. All right, so I can tell you that that's identical to mine. That's a good sign. What about C? And that's different. Yeah. I mean, not that much, but mine is different. Not crazy different. And then fuse the two together. What else? Delta. What about delta? Delta will be different, of course. Oh, yeah. Mine is a super tiny number. Yours is a huge number compared to mine. Mine is 1.4 e to the minus 306.
Oh, wow.
It's actually pretty singular at the beginning. That's weird. But why? I mean, C is identical, right? Is it? That's crazy. Let me actually write it in MATLAB here. So if I write C, can you do the same? Can you write C just to see the entire matrix? That's not possible. So mine has, where you have the 0.039, I basically have zeros. But other than that, well, I guess that would make a difference, right? But other than that, mine is it's the other values are pretty much the same, very close. So what's happening? Delta is the determinant of CC transpose, right? That's interesting.
Yes.
That is really interesting. Wow. That doesn't make any sense. If me find an error into mine, I'm gonna quit. Okay, this is interesting. I just computed the determinant of CC transpose in, oh, forget it. It's not decimal, as I said. Actually, I haven't even computed it yet. Sorry. So now I have it. Well, still, so mine is 7, 10 to the minus 7. So it's small, but not as small as before. That was just, I don't even run the instructions. So it still doesn't explain why yours is that, or mine is this.
I mean, I don't know.
Yeah. But the C matrix is very similar. ISW is what? Let's just look at the single variables here. ISW
Okay.
is passing at 0.1, and that's fine. Yeah, we can look at AT. I don't know that I have it somewhere. What is it? A? Oh my goodness, what is A? Why don't I use A? Oh, it's T. Okay, for me it's T. Sorry.
Yes, because
Yeah. Sorry about that. That's a T. So that would be T1, T2, T3. So T1 is 0, 0, 1. Yeah. T2 0, 0, minus 1. Minus 1, 0, 0. Fine.
Okay.
The Y that is coming through, it's that point, whatever. Point, yeah. Can you go over? 0.03, 0.13. Yeah, that's right. What is your omega? Your omega values is what? Oh, I think we have completely different initial omegas. Omega of the wheel, actually. Yeah. No. The wheel. The M
where
matrix,
is
the one
it?
on top.
Here. Okay, sorry.
Okay, that's identical. Fine. The omega of the spacecraft, I have 0, 0, 0. What do you have?
No, I have.
You don't have 0, 0, 0.
No.
You have a pretty fast, actually, rate. Again, you're not using the initialize.
I have the initial conditions for. Let me check.
So
These ones.
Yeah, no.
Okay.
I think that was for the previous exercise. I did give you the initialize for homework too, did I? No?
Yes, but I think I just confused the first initialize with the second one.
No, but I may have forgotten. I mean, it's. Do you all have it? No? So I'm gonna send it here in the chat again, just in case. I'm gonna send the file here. Upload from my computer, yes. Oh gosh. Yeah. So this should be the one. Do you see it?
Not yet. Okay, now I do.
So you have some modifications to make because you've defined other vectors, but
So it should be 0, the initial angular velocity of the spacecraft.
That's what I have. In your case, you have a point in radians per second. You have 0.5.
Yes.
And I'm wondering what that's doing. It's half a radian per second, right?
Yes.
So your initial angular velocity is like 30 degrees a second on each axis. Why is it making a crash? Assuming that that's the problem.
Let's see.
I don't know.
sorry. How do I stop this?
Just quit debugging, the big red button to the right, top right.
Ah, okay.
And you want to clear all the breakpoints if you just want to run the whole thing and see if it works.
Set clear.
Clear all, so you sure there's
okay.
nothing. Yeah, I was gonna say. Well, did you add your line that actually defines? Oh man, the same, isn't it?
Yes, it's the same.
Not really. There's no singular matrix now.
Yes, it's still derivative is not finite. But it's not saying that there's a singular matrix. I don't know.
Okay, let's go back into the block and debug more. And then you can continue because we're reaching an hour here. But so yeah, put a breakpoint into the same block we were before with the matrices.
So I should go here?
No, go into the function, not this one. I don't think it's this one. I don't know.
No, sorry. What is
we
this
were
one?
working on a different. Go ahead.
I had the same problem of Maria, but I think that how did you define the initial condition of the integrator that integrate the omega dot as the outcome of I don't know how you call it. I can share you so the screen.
You mean this one, the numerical integrator? Oh.
Yes, because the
no, it's capital omega with 0.
Okay. Yeah, to me, this is the problem. So you have defined in a wrong way, and then it work.
So, do you want to share?
Okay.
So the omega of the wheel, yeah, it's called OM0 with the
Capital Om.
Yeah,
yes.
Okay. Here. Omega dots that comes from here, that which is the components of the eta.
Yes.
I wrongly defined the initial condition here with OM0. Now it is working, and OM0 is if it is the same or the last initializer file.
It's 500 RPM if I'm not mistaken. Yeah.
This one.
Let me check.
I had same problem, just the same, and with this change now work.
Very good, thank you.
I don't know if the results makes a sense, but at least it's.
Can you run it and show what you have?
Yes, I had a problem with the plot functions, but
No, it's the right one. I used the right one. But thank you.
No okay. I think you know now that you know how to put a breakpoint and look at variables step by step, maybe it's worth going through that exercise. Oh, it's not plotting. Okay, that's fine. I actually have to go. I have another meeting, but we can definitely continue debugging tomorrow. Or do you want me to leave the meeting open so that you can keep working together, or I can do either way?
I don't know. It's okay for me. Yes.
Okay. Yeah, let me know how it goes, and we'll resume tomorrow.
Okay, thank you.
All right.
Okay.
See you tomorrow.
See you.
Thank you. Bye.
Bye.
Thank you.
Thank you. Bye.